Hello Mohit, how are you? Okay, I'm also fine. So Mohit, do you have any query regarding this course or you want to say something? Any feedback regarding this course, this product design and manufacturing? Or you want to know anything about examination or anything? Okay, so you're talking about full course, huh? Uh, okay, so today it is not possible. Maybe next week I will prepare a brief of all the lectures that are covered till now, and then I will cover like I will brief the all the lectures and the topics that are covered till now, like till week 7 course content. So maybe next week I will prepare the slides and the content for that. Is it fine? Although I was planning to revise this in the last week because we are we are in the like this is the sixth live session and we are doing covering the course content of week 7. So in the 12th session I think uh, we don't have uh, any courses or any content will left. So in that particular session I will be revising all the content like full course, that product design and manufacturing from first from week 1 to week 12. But as you are saying, next week again I will like is it the course is like on the midway, half of the course is completed, so I will try to check out the topics and I will try to prepare the important topics for the examination, and then I will briefly what you can say, cover the and revise for your revision. I'll make some content and then we'll discuss it. So next week I will do that. So kindly join the class next week again positively. We are waiting for a few other participants. Let them join and then we'll start today's session. Good afternoon, Nikhil. How are you doing?
I'm good, sir. Thank you.
Nice. So, like Mohit said that he want brief revision of the course. So I was telling in next week I will be like the in the session only I will be covering the important topic till week 8, and then like a revision in a revision mode I will be covering all the topics so that it will be a kind of revision for you guys, because the course is in the midway. We have crossed week 7, and total we have week 12, like 12-week lectures. 12-week course content is there. So next week I will be doing a revision kind of thing for all the topics that are very important for the examinations and all.
Okay, sir. Yeah.
And then again in the 12th, when I will be taking the 12th live session, then a full course revision that is already planned by me. So I will be taking two revision class, two revision, one in the midway and another in the like last session for my this course. It will be the revision class only, and the 12th session will be revision one just before your examination.
Yes, sir. Great.
Maybe in between, one live session from the course faculty advisor will also be scheduled from the NPTEL side. Maybe you all will get mail. Okay, Sanjay, you are sharing some jam file. Okay, so let's begin the session. Like there are few participants. They others may join later. So hello everyone. Again, I welcome you all in today's live session. This is a sixth session that I'm conducting for the course Product Design and Manufacturing. I'm Sarit Anand Singh, a PhD student in the Department of Mechanical Engineering, Indian Institute of Technology, Jodhpur. I'm a PMRF fellow, and through PMRF NPTEL TA scheme, I got this opportunity. This is a very wonderful opportunity to interact with you all, to attend you all in the live session mode and address your queries, interact with you, and uh, learn this course also. So uh, we are in the sixth session. Today is the sixth session, and we are covering today the course content of week 7. So we are running 1 week ahead because of the like course, as the course is moving. So maybe next week, Friday or Saturday is the last day for the submission of assignment of week 7. So before that, we have to discuss that the course content of week 7. So we are ahead of this, like uh, so, as those who are new, I just briefly explain that how these sessions are conducted. So, in this session, I will be taking this session. I will taking in three parts. The first part, I will be covering some questions that I have already prepared for you. I will be asking questions that are objective type, a similar question that are in the assignment, and that will be asked in your final examination. So, I will be asking the question, and I hope you guys will participate in answering those questions. And while answering those questions, we will be discussing about the topic which is relevant to that particular question, or whatever discussion is required or important at that particular moment of time. Then after completion of that particular section, we'll move to the next section. That will be the question from discussion forum. I will be taking the questions from the discussion forum that you or the participants of or the learners of this course have asked on the Google, on the discussion forum on the NPTEL portal. So I will be taking questions from there. And in the third session, this session will be open to you all. And if you have any query or any type of issue regarding this course, product design and manufacturing, you're free to ask those questions. I will try to answer your queries. And if today it is not possible, I will definitely cover or answer your query in the upcoming live session, that is next week. So this is how we move in this live session, because I'm seeing a lot of new people today. So I hope you guys will be like enjoy, and uh, also you will get some fruitful knowledge and information, and a kind of revision for the particular week 7 course. So what I expect from you all is the participation while answering the questions. And second thing, maybe you have gone through at least once the course content of week 7, so that will be very helpful for you. And if you participate in the uh, live session, that will give me some extra energy and motivation to conduct this session with more energy and more efforts. So that's all. So let's begin with the first part of this session. So I'm going to ask you some questions. The questions and options will be displayed on your screen, and then I want answer from you guys. Kindly participate in answering the questions. So the first question is going to be on your screen now. It's a true false type question. It is a general statement which is in the lecture slide only. So it says 80% of the environmental damage of a product is established after 20% of the design activity is completed. So is this statement is true or false? Like 80% of the environmental damage of a product is established after 20% of the design activity is completed. So when we are uh, designing a product, and it's 20% designing of the product is completed, so that at that stage only 80% of the environmental damage is established. So Shiva, please turn off your camera. You are not wearing any shirt or something, so yeah, thank you. So we have got some answers. Okay. So So Sanjay says B, and other options are A. Okay. So yes, if you have gone through the course content, so this statement is absolutely correct, because when we are in the initial phase only, like only 20% of design activity is completed, at that stage only we have information about the environmental damage, or whatever is the effect of our product, or the things that we are using, or the process that we are using on the environment. Okay, so at the very early stage we used to identify the environmental damage. Okay, so this statement is correct. So it is the answer for this question is true only. Now second question is on your screen. It's a very important question. Which of the following activities come in 3 R's principle? So 3 R's principle, I hope you all know what is 3 R's principle. So which of the following activities come in the 3 R's principle? Okay, so everyone is answering same. All of these. Yes, definitely. So 3 R's principle itself, like there is 3 R: reduce, reuse, and recycle. So we have to reduce the consumption or utilization of those product or those materials which are harming the environment. Okay, like we are planning to we always, or as a firm or any product designer, or as a human being, again, we try to reduce the consumption of those products which are harmful for the environment. The very good example for that, this reduction in the consumption of that product is of plastic. Okay, so plastic is a material, is a what you can say, the plastic made this product we always used to avoid. Okay, as a what you can say, as a good human being, we always try to minimize the utilization of that plastics, because that is environment, that is damaging the environment, as we all know. Then we reuse the things that are reusable. Okay, again and again we can use, like if we are drinking water in a bottle, so we can refill it again and again, and we can use that particular bottle. So like reusing that same thing again and again. Okay, and then recycle. So there are certain products that can be recycled. Okay, so there are certain processes that came in, and people are also researching about how to recycle the plastics, so that, because we are reducing the utilization, but recycling is also important. And then for other product, there are lots of product where recycling of the things are already happening, like the glass bottles. So the glass bottles that are there, so the glass is a recyclable material. So we used to recycle it, and we used to make some other component from glass to bottle to some other what you can say artifacts. Okay, so these are the three R's that are very important for not only as a perspective of a product designer or any manufacturer, but also as a human being. So we always need to follow these three R principle, that we have to reduce those products which are damaging the environment. We have to reuse those products which is possible to reuse, and we have to recycle all those components which are recyclable. So yes, all the activities reduce, recycle, and reuse are covered in the 3R principle. Now we are moving to the question number 3. It's a numerical question. So it's a question from quality control. It says find the upper limit of the control chart. So we have to find the upper limit. I just highlight the important terms. So we have to find the upper limit, okay, of the control chart. So we are here in the control chart. Okay, given that the average value is 14, so the average value of the quantities or the readings that we are taking is 14, and the standard deviation of the characteristics is 15. So standard deviation is given as 50, and the distance from the center line is 4 units. So the distance from center line is also given, it is 4 units. Now we have to find the upper limit of this particular control chart. So kindly calculate the upper limit of this control chart and come up with some answer. Options are given: 56, 14, minus 46, and 74. So kindly calculate it and come up with uh, some answers. So for those who don't know what is control chart, or they hadn't studied or they hadn't gone to the course, so I'm just drawing a sample control chart. So control chart, what it does, so with respect to time, or with respect to uh, what you can say number of samples, so we used to take readings. Okay, so that readings will be like, if we are suppose we are a manufacturer of some what I can say, some bottle cap. Okay, so like this bottle cap we are manufacturing. Okay, so this has some diameter. Okay, so after producing this bottle cap, there is some diameter which is required. So what is this what we can do, either with respect to time or with respect to number of components, we can take reading of this diameter. Okay, so suppose at y axis there will be diameter. Okay, and here like with number of components, like first component, second component, third component. So like number of components. Okay, so number of that bottle cap which we are producing, so this number is there, and diameter is on the y axis. So what we'll do, we'll take some reading. So suppose some reading will be like at the for first component, it comes like this. Okay, so we have some desired value that we want. Okay, so like suppose we want 5 unit diameter to be 5 unit. So suppose first will be something like 5.01, maybe some deviation. Then in second, something is again 5.5. Then third, and then maybe some fourth will be lesser than 5. Okay, so this kind of value collection, this kind of collection we used to do, and then we used to plot a chart. Okay, so there is some like mean value that is there. Okay, so it will be something like that. This is a mean value which we required, and then there is a mean value which is coming out of all the sample that we have observed, and we have the data we have collected. Then there will be a straight line. This is a straight line. I'm sorry, like it is not looking like a straight, but yeah, it is a straight line. So this is a control line. We say this is a control line. Okay, so So people are joining till now. So this is the control line, and there is a upper that is upper control line, and then there is some lower control line. So these both are all lines are straight line. Okay. So this is upper limit. Okay, upper control limit. This is lower control limit. Okay. So yeah, so this is a an example of control chart. Okay, how we used to draw it. So a numerical question is there, where we have to find the upper limit of a control chart, which is having average value of 14, the standard deviation of 15, and distance from the center line is 4 units. So we got some options. Sanjay said C is minus 46. Nikhil has done a calculation and then he's saying 74. 14 plus 4. It is 74. Okay, so option number D. So any other answer? We got two answers. 74 and minus 46. The important terms that we need to verify is these terms. Upper limit, we have to calculate the upper limit of a control chart. Okay, we are calculating the upper limit, where the average value is 14, standard deviation characteristics is 15, and the distance from the center line is 4 units. So I expect more answers because uh, many of you are here. Any other answer? Okay, so let me solve this question for you. So answer is D, definitely 74 is the answer. And how this answer came? So uh, okay, so I have to rub it. Yes. So what I said, we have to calculate the upper limit. Okay, so the formula for that upper limit is the average value that is given. The average value given here is 14. Okay, is added with standard deviation. So ST. Okay, is a spelling mistake. It is A. Okay, so it is standard deviation multiplied with the distance from the center line. So distance is given as 4 unit and the deviation is given as 15. Okay, so we have to multiply 15 with 4. 15 into 4 we get 60, and then we have to add the average value, that is 14. So 60 plus 14 is equal to 74. Okay, so this is the answer. 74 is the answer for this particular question. So I hope you all are able to solve now this question. Okay, you all can solve this question. This, if upper limit is asked, you can use the formula. Upper control limit is equal to average value plus standard deviation multiplied by the distance from center line. Okay, so this is one question. Now again, kindly note down the, is the center line value also called the target value?
Sir, that average value which they have given, is it same as target value or?
No, 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 no.
Oh, sorry,
So it
sir.
is it is not the target value. It is the average of the average of the values that we are getting while collecting the samples. Okay.
Okay.
So in the control chart, the values that are true values. Okay. So
Mhm.
that is the average value is the average of those true true values. Okay,
Okay.
so in the chart, the values that are mentioned, so the average of those values is the
Mhm.
average value, right?
Okay.
So what I request you all to write down this given values, because we are going to again use the given values again in the next question. Okay, so the given values are: average value is 14, the standard deviation of the characteristic is 15, and the distance from the central line is 4 unit. So kindly remember, like note down on a paper so that we can use it in the next question. So again, the next question is also a numerical type question. So I hope this is now clear to all how to find the upper control limit. Okay, so is elaborately discussed in the class. In the course content, the formula is given. This formula can be directly used for calculating the upper control limit. Okay, so this kind of question you can expect in the examination again. Okay, now we are moving to the next question. Question number 4. Again, it is a numerical type question. What I already asked you to write down the data. So from the same data given in the question 3, okay. Now we have to find the lower control limit. In the question number 3, we have find the upper control limit. Here we have to find the lower control limit. So kindly calculate the lower control limit. What is the lower control limit for the given data? Okay, so first answer we got is minus 46. Okay, Sanjay is also saying C. Nice. We have two answers. Okay, Nikhil is saying C. Three answers. Three answers on C. Any other answer? Okay, so let's see what is the formula for calculating the lower control limit. The answer is minus 46 only. So the lower control limit is calculated by the formula, which is average value, and then we have to subtract the product of standard deviation with distance from central line. Okay, so at place of plus we are like addition, we are subtracting the values. Okay, so in upper control limit we are adding these two values. In lower control limit we are subtracting. So by subtracting, like 14 minus 15 plus 4, that is 60. So it will be minus 46. So the answer is minus 46. Okay, so you all can expect this kind of question in the final examination also, which are directly based on the formula, and a minimal calculation is required. So this kind of calculation can be done without taking the help of calculator. Okay, so this kind of questions are important for your examination also. So I hope you guys will be able to now calculate the values of this upper control limit and lower control limit if similar kind of question is given. Okay, so there are lots of other control charts. There are lots of other formula that you have to like revise it. The formula that you have to just have a overlook on those formulas and how the values are calculated. Okay, now moving to the fifth question. Question number 5, again, it is a numerical, but it is a different kind of numerical. It says if the probability of a point that will exceed the control limits is 0. 1, 0.10. Then find the average run length. So there is a average run length. We have to find the average run, the value of average run length if the probability of a point that will exceed the control limit is 0.10. So the probability of exceeding the control limit is 0.10. Then we have to find the average run length. What is the average run length for that? Again, this is discussed in a very elaborated manner in the class. Okay, so if you have gone through the course content, you must have seen what is average run length, and you will be able to answer this question because it's a very easy question. Okay, so we have two answers. Sanjay saying A, Nikhil is saying C. Sorry. Okay. Any other answer? Okay, so the answer is C only, and the formula for average run length is 1 divided by probability. So it is inversely proportional to the probability average run length. So the probability is given 0.10. So if we divide it like 1 divided by 1.0.1, it is 10 only. So the average run length is 10. Now, question number 6 is on your screen. It is a true false type question. It says life cycle analysis is not an appropriate technique for assisting management in costing and designing an environment friendly manufacturing facility. So life cycle analysis is not an appropriate technique. It is given not. The statement is itself a negative statement. So it says this technique, life cycle analysis, is not an appropriate technique for assisting management in costing and designing an environment friendly manufacturing facility. Okay, so everyone is answering B. Yes, it is a false statement because life cycle analysis is a very important technique for from where this management got an idea about the costing of the product and also uh, designing an environmental friendly manufacturing facility. Okay. Question number 7 is on your screen. It says, which of the following is a graphical display of a quality characteristics that has been measured or computed from a sample versus the sample number or time? So out of the four options given on the screen, control chart, cause and effect diagram, scatter diagram, and none of these, which of the following is a graphical display of quality characteristics that has been measured or computed from sample versus sample number or time? So I already discussed about this uh, in the recent discussion. So what is this called? Okay, so we got one answer. A is control chart. So yes, three answers for A. Yes, this is a control chart only. So in control chart, we used to compute the value of like sample versus sample number or sample time. So we used to uh, extract the dimensions or some other samples, other values, okay, other attributes with respect to number of samples or maybe time bound. Okay, so it is a control chart only. Question number 8, again it is a fill in the blanks type. Which of the chart represent the variety in the data? So which chart represent the variety in the data? So if there is a variation in the data, which chart is preferable? Charts, there are numerous charts. So R chart, X bar chart, X chart, and none of these. Okay, so we got options for A. Okay, yes. So it is a R chart only, which represents the variety of the data. Question number 9 is on the screen now. Question number 9 says, which of the item is a unit of product that does not satisfy one or more of the specification for the product? It is a confirming item, non-confirming item, both of these, or none of these. Which of the item is a unit of product that does not satisfy one or more of the specification for the product? It is not satisfying the specification of the product, so it is non-confirming item. Okay, so if the item is satisfying all the specification of the product, it is a confirming item. Question number 10, it is a true false statement. It says the control chart should be applied either to control error or to sequence of adjustments to the manipulated variable. Is it correct statement or a false statement? Control chart should be applied either to control error or to the sequence of adjustments to the manipulated variable. False. So it is a true statement, because why we apply control chart? What is the purpose of applying control charts? What is the purpose of collecting the data? So with the help of all those collected samples, collected data, what we do, we use to control the error. Okay, so suppose if you are working on a any continuous production line, like that is a mass production line. Okay, we are producing a same component in mass. Okay, so we used to access the attributes. Okay, so it may be surface attribute or maybe dimensional attribute. Okay, so we used to access those things, and then if there is like the values are going out of the limit, okay, out of the tolerance zone, so we used to look at the cause for that, and then we used to rectify those errors. And this is all what is the purpose of control chart. Okay, so quality, in the quality assessment, we use this control chart for that particular controlling the error and adjusting the manipulated variables. Okay, so these are all the 10 questions that I have for you all in the today's which are related to the week 7 of the course content. Okay, now again this week we don't have any question on the discussion forum. Someone has asked about what is the importance of this course in getting job or something like that. Okay, so that is not the scope for answering. However, this particular kind of course always boost your knowledge and information about the particular what you can say, in the particular field of product design and manufacturing, and then you can utilize your knowledge for betterment of your particular institution, or maybe uh, that will help you in the upcoming interviews, or whatever you are going to face. You can show your certificate, and then you can what you can say, make your interviewer to ask questions related to product design and manufacturing. And if you will able to answer the questions that he have, you will definitely get some positive points in your interview. Okay, so this is all the and important thing is that this kind of course and this kind of knowledge is now required in the industry, because people are generally used to study engineering or maybe marketing skills or something like that. But if you have add-on no, what you can say, add-on knowledge of product designing and manufacturing also, so that will be definitely help you to boost your, what you can say, uplift your career. Okay, so this is what how this course is help will be we can help you, okay, in your future perspective. So now the third session, it is like uh, you can ask your question, and now the I will be able, if I will be able to answer your question, that is fine. Otherwise I will note down your question and I will try to answer your question in next session. So can you please guide about target variable in SPS SPC?
Sir, target value in statistical process control. So I heard
Uh-huh.
I got a bit confused between target value and, as I asked you in that earlier question, and average value you had given, right?
Uh-huh.
The line which
Okay.
runs centrally, is it calculated? Right? It is calculated automatically calculated based on number of observations, right?
Yes,
Will be an
yes, yes.
average simply, like
So
10
that is the average value of the samples that are collected. Okay.
Okay,
Target value is something which is already defined by the designer.
okay, okay.
Okay, so
Uh-huh.
suppose if you are like we have taken the example of that cap. Okay, so this bottle cap, if we are manufacturing this bottle cap, so before manufacturing is started, a designer has designed this for some particular use with some particular bottle. Okay, so
Mm-hmm.
the diameter of this cap is already defined, okay, in the design level itself. So suppose it is defined as 5 millimeter of the diameter. So while manufacturing we have to look, and then with 5, not 5 only, it is also given with some tolerance value. Okay, like 5 plus minus, there may be some error of maybe 0.1 So if the diameter is like 4.9 or maybe 5.1 and in between that, so the product is acceptable and it will get fit on the bottle, that where it is going to going to be fitted. Okay, so with this tolerance value and this particular target value, so this is the target value which is given. Okay, so 5 plus minus is some value which is predetermined, it is a target value. Okay, we have to achieve it while manufacturing. But when we are manufacturing and we are accessing the values, we get some real values, right? So it may be 5 sometime, it may be 5.1, it may be 5.05, or maybe 5.5, or maybe 4.5. So all these values are plotted in the control chart.
Okay,
Now in the control chart, when we average those values, that collected values, that is the average value of that particular observations. Target value is the value that is like the predefined value, that is 5 which is for this particular example. Okay, so that is the target value that we have to achieve.
okay, okay.
Okay.
Yes, sir.
Any other question? So now discussion from my side is over. It is all up to you guys. If you have any question, you can ask it to me. Otherwise, you can feel free to leave the meeting and we'll join. We can again meet in next week. I will be here for us for solving or the queries of the student or the learners who will be joining late or maybe till 5 p.m. is the time. So I will be here only. If you don't have any query, you can feel free to leave this meeting. Thank you.
So one question from me.
Yes, yes.
Hello.
Yes, Ram. Yes.
Yeah. Yeah. Sir, I want to know how house of qualities and voice of customer and how those are all interlinked, and is it done while before designing, or how is it, sir?
Okay. So the quality assessment of the product is sorry. So quality assessment of the product is done at the manufacturing level. Okay. So uh, there are certain kind of what you can say quality control that is taken place. So while at designing stage, we used to design our product in such a way that if it is going to assemble with some other products, okay, so like we have taken example in the today's class, that bottle cap. So if we are designing the cap, then we know that this cap is going to be fitted with some bottle, okay. So in the design phase only, we used to access the value of the diameter of the bottle neck on which that cap is going to fit. So in the design stage, we clearly define that the diameter of the cap with respect to that bottle, the neck of that bottle. Okay, so this is one phase. While manufacturing, when this design goes to the manufacturer who is going to produce that bottle cap, so he has that particular design of the design and the dimensions. Okay, so we need a circular like it is a circular kind of thing, so diameter is defined and with some tolerance limit. So he instruct the workers on the like with the help of some machine or some process, we are going to manufacture it. Okay, so those who are performing the operation, they are instructed that they have to produce the component with such limit, with such constraints. Okay, so while manufacturing, they use some machine, some process, they try to manufacture those product with in that certain limit. But it is not guaranteed that they have produced, although they have used their own expertise and experience level and best possible what you can say manufacturing process, but it is not guaranteed that particular product that is produced is in the that particular that is conformance with the design, that particular design which is given to the manufacturer from the designer. So what happened at that stage, there is inspection, their inspection is taken, inspection is takes place. Okay, so it is like it may be in the current era we want 100% inspection, so each and every component is inspected. Or maybe if it is not possible like for 100% inspection, so what is there, sample inspections, like a lot of maybe 100 or 1000, or depending upon the rate of the production. Okay, so lots, from a lot of product, there is some samples are collected, maybe 10 samples or 10-20 samples are taken out. So if that, suppose this bottle cap is manufactured, so it is manufactured in masses, so maybe from thousands of when the 1000 bottle caps are manufactured, it is a lot. So from that thousand, those 1000, we used to pick some 10 components randomly, and then we used to the quality inspector, is a quality inspector, a particular dedicated person on the manufacturing line. He used to inspect the diameter of that. If the diameter of that particular those 10 component, 10 bottle cap, if he has taken, is lying in with the uh, according to the design, the required design, like if it is 5 and some plus minus 1, so if all the 10 is lying within that, so he will accept that particular lot. Okay, and if it is not, like one or two component is not lying in that, like suppose some component has like 4.5 diameter or maybe 5.5 diameter, so he will reject that particular lot. Okay, so once he will reject that particular lot, so there will be again a rechecking, and some other processes are taken place on the manufacturing line to reduce this error. Okay, and then again to make the product with the required design. So at the manufacturing stage, this quality inspection and like after manufacturing and before dispatching, this kind of quality inspections are taken place. Okay, there is another quality inspection kind of thing which is now in trend, like in process. So when the product is getting manufactured, so some machines are equipped with their own feedback kind of thing. So there is some measurement techniques are applied while the component is getting manufactured. So it is not possible for like the component like this, which is manufactured one in a one go. So like suppose a component is manufactured in 3 or 4 steps. Okay, so after completion of each steps, the products are inspected, and if there is some deviation in the required dimensions or any required characteristics, so in the subsequent stage it is corrected. So these are all the quality inspection and quality inspection techniques that are used in today's manufacturing industries, and it is in practice now. Okay.
Thank you, sir. Thank you. So one more question, like
Yes.
see, on the tolerance level, right? On the tolerance level, which is
Mhm.
sorry, provided onto the any component, right?
Mm-hmm.
So, is there any way that to check the tolerance provided is right, or is it required, or is it what is specified is over specified, so that we can reduce the process?
So this is like this is the tolerances and everything is defined while designing stage. Okay, and while designing we have to follow some standards. Some standard rules are there. ISO standard rules are there. So the designer used to follow those particular rules, and then only he used to define the tolerance level. And then again,
Yeah.
these rules, this tolerance limits and values are defined for the product to product. So suppose
Yeah.
a product which you are manufacturing is very critical component, like it is going to be used for some machines which are going for military operations, or maybe automobile or aerospace industry, okay, or nuclear industry, or some in power plant. Okay, so if the component is for critical industries or for critical application, so the tolerance value are very specific and conformance with the what you can say, the standard. The ISO standard itself is very what you can say, difficult or hard or very strict. Okay, that are very stringent kind of thing. But if the same component, if you are producing, it is going to use for some commodities product, like what we are taking the example today is the bottle cap. So the tolerance for this cap and bottle, maybe it will be slightly less, slightly wider than that of the tolerance value which are for the product which is going to use for a critical applications. Okay, so while designing
I
only
understand.
the ISO standards are followed, and according to that design, the product designer put the tolerance limit.
Okay. Okay. So is it, can it happen that the designer has given over designed it with a critical tolerance level, and that can be found out? Is there any way out to do that?
Can you repeat your question?
So for a shaft, he has given a tolerance of 10 plus or minus 0.001, but
Mm-hmm.
the function is not required. So is there any
Mm-hmm.
way out there to tell that you for the function what it is going to be, you have given a very tight tolerance which is not required, and reduce my process? Is there a way out to do
Yes.
that?
So yes, this can be done, or this can be altered. Like in the what you can say, this is the communication between the manufacturer and the designer. Okay, and
Yeah.
the one who is going to like consumer. So like in the industries where this kind of thing happens. So suppose there is some MSME, small scale industry, who is producing these component, and then there is a bigger industry like OEMs, original equipment manufacturer. They are going to consume those for building some
Yes.
okay, some bigger machines. So OEMs can initially define their limits. Okay, and if those limit, if the manufacturer is not able to process that if the manufacturer is not able to manufacture the component with the that particular desired limit from the OEM, so he can communicate with him. If maybe is there like OEMs don't want such a strict limit. Okay, so they can communicate back to the manufacturer that you can, yeah, relax on the tolerance side. We can accept a bigger tolerance zone for particular product. So that all can be done based on the requirement and the consumption of the product.
No, this is manual, but is there any software or a package available which checks this? Yeah.
So I think this what you can say, these standards are already amalgamated with the or augmented in the drafting softwares. Okay, so
Okay.
uh, if you use like this SolidWorks or CATIA or something like that for designing a particular component, so if you put the material and the what you can say, the standard, so it will automatically define the limits. Okay, automatically give the tolerance values. But like
Okay.
what you are saying, what you are demand with the knowledge of the application, some automatic tolerance limit is there. I
Yeah.
don't think so there is any application, like I hadn't used maybe there are some applications, but I right now don't have any information for regarding that.
No, yeah, thanks for that. Yeah, thank you.
Uh,
Yeah. So will we be studying GD&T also in the course, or I don't know. So just
uh,
out of curiosity, I'm asking.
uh, uh, so I also don't know, like, that we are going
Yeah,
to study or not.
fine.
Maybe if we are going to study, so in the next this particular current week 8, uh, that
Uh-huh.
will be covered. Okay, let me check the
Mhm.
syllabus. Maybe if it is given in the syllabus. So quality assessment was there, but maybe GD&T. I have to check it.
Yeah, that's fine. Yeah, thank you.
Thank you. Thank you.
And I'll be dropping out. Huh? Thanks.
Okay. Okay. Yeah. So, is there any other question? Yes, Monish. Do you have any question? So question paper pattern is similar to the questions that I am discussing in the session, and also the assignment questions. Okay, so it will be objective type questions. So maybe true, false, maybe match the following, or fill in the blanks. Okay, so these kind of questions will be there. Maybe some numericals with some options. So objective questions will be there, and options are given for the questions, and you have to choose the correct options from the given options. So that this is a similar pattern with the questions that are in the assignments. Okay, thank you, Manish. So if you have any query, you can feel free to ask me. uh, I am here only. You can ask about your query regarding this course if you have any. So Mriganga, from my side, discussions are over. If you have any question, you can ask me. If you have any query regarding this course.
So Uttam, from my side, discussions are over. If you have any query, you can ask it to me. So Khush, from my side, discussions are over. If you have any query, you can ask it to me.
Okay, so this is all for today. We will meet again on next Saturday and same time to cover the course content of week 8. And in next session, I will try to revise the course content till now, and then we'll discuss specifically about the course content of week 8. So that's all for today from my side. Thank you very much.